It doesn't matter what country you live in or what industry you build a career in. STEM skills are increasingly important, particularly for children and students who are yet to join the world of work. Introducing robotics to children at a young age in the same way that we enroll them in soccer or piano lessons should be a real consideration. However, the participation costs are often so prohibitive that it's out of the question for most schools and parents. Today's guest, Jared Schrieber, wants to change that. He envisions a world where there are as many elementary and high school robotics teams as there are basketball or football teams. That's the vision behind Revolution Robotics, a nonprofit dedicated to making robotics hardware and software kits accessible to all communities. Welcome, Jared. So great to have you on the show with us.
Thanks so much, Peter. Really appreciate it.
Now, Jared, of course, I want to dive into Revolution Robotics with you and your work and vision there. But before we do that, you actually have a whole trajectory. Before Revolution Robotics, you started your own company, InfoScout. Can you say a bit more about that?
Sure. So prior to Revolution Robotics, I'm a serial software entrepreneur, the last company being InfoScout, now known as Numerator, where we created mobile apps that incentivize people to take pictures of their everyday shopping receipts, no matter where they shopped or what they bought. We would then read out the item level contents and provide analytics to brands and retailers to understand them, response to advertising and promotions, response to new item introductions, and all kinds of other brand-related insights.
Now, InfoScout became Numerator. Can you say a bit more about that? Why did it get renamed and why are you not there anymore?
Well, I had that very good fortune that I think every entrepreneur dreams of, which is to have an exit. And I had the good fortune of merging my company with a larger company. We renamed the two based on what the two could do together, and that was Numerator. And so now it's a company that's a part of the Cantor Group, which is the world's largest market research company globally. And it gave me an opportunity to step back out of being CEO and running the business day to day and do things that I'm perhaps a little more passionate about, such as this.
It's pretty much every entrepreneur's dream to, build a company successfully and then have an exit and get a chance to take a step back and think about what you're going to do next, right? How was that process for you?
When an exit happens, it happens so fast. You just can't digest it all. It's in a way, to be frank, it's a little bit anticlimactic. You realize through the process that the journey had to be the reward because the actual event of the exit itself turned out to be a conference call at 6 a.m. that was as dry and boring as could be to dot the I's and cross the T's, and that wraps everything up. And then you take a step back and you say, wait, I'm done. Now what? What do I really want to do? And fortunately, while I was still building the company, my oldest son, who was a fifth grader at the time, joined his school's robotics team. And it was the first year that the school had offered robotics as an after-school program, much like basketball or some other sport. And one of the parents was the team coach, and he was a NASA engineer. And within a week, he sent out an email to all the parents and said, help, to which I went, oh no. And I asked him, what kind of help are you looking for exactly? Because I don't know much about robotics. I know software, but not robotics. And he said, oh, great. Really what I just need is a parent's help here. So I started helping out with my son's robotics team. And what I quickly saw and learned was, my gosh, is the system complex, what they were having to have the kids do in terms of installing and configuring all the software on the computers, on the firmware, for the brain of the robot, for the motors of the robot, for the sensors of the robot, and all of it had to sync together. It was just really complex to get everything started up and going. But once we figured that out and got through it, actually the experience for the kids was fantastic. And my son's team ended up doing very well, going to the world championships for the program they were doing. Oh, it was fantastic. And,
wow.
and my son had a great time. And as a result of that success, it seemed like every kid and their parent wanted to be a part of the robotics program next year. And that wasn't going to work with a team of a handful of kids. And so what my wife and I did is turn our garage into a robotics lab for kids. And
oh, wow.
I started coaching multiple teams at the school. We'd meet in our garage. My daughter saw some of her friends doing it. She joined in. year later, we had a girls team and a boys team and a mixed team. And within 2 more years at the school, we had 16 robotics teams. It was incredible. It was just amazing what came of that and what could be if the right kind of structure is put in place around it. And so, long story short, when I exited from InfoScout, I had a chance to say, what do I want to do now? And I thought back to the experience of how amazing it had been for my kids to go through this kind of competitive organized robotics and everything that they'd learned and experienced from it. And I said, you know what? The current programs out there are too expensive. They're too complex. The competitions really aren't that fun or fair compared to what they could be. And the only way that this is going to get solved is somebody takes a different approach than what's been done before to really lower the cost, complexity, make it much more accessible to kids out there. And so that's really what I set out to do with Revolution Robotics.
And that's amazing. Now, where were you based at the time?
Yeah, so I was in fact transitioning. My wife is Hungarian, and as part of having an exit, it gave us an opportunity to rethink where do we want to be? Where do we want to raise our kids? And so, Silicon Valley is amazing when you're building a tech company and a career, but as a place to raise a family, quite frankly, it can be challenging. And so we decided to get closer to her family in Budapest, Hungary. And so we've lived here for a few years now, and one fortunate thing about being in Budapest is there's some amazing engineering talent here, particularly in the field of mechatronics and robotics. They have an outstanding program at the top university, and so I was able to connect with some amazing talent here to help me bring the first Revolution Robotics Challenge Kit to life, which was an open source project where we leveraged a bunch of existing open source technologies to build the hardware that is the basis of our first kit, the Revolution Robotics Challenge Kit.
So I'd love to understand this journey a little bit better, Jared. So when you had the first round of robotics competitions with your son, and then it grew to 16 teams in one school, was that still in Silicon Valley?
In Los Altos, kind of the heart of Silicon Valley there. And quite frankly, the kind of thing that can only happen in an environment where you have a whole bunch of engineers and scientists and techies as parents and family members, right? So it made it easier to train them to become mentors and coaches of teams. Whereas you can imagine in other parts of the country, it's just not going to scale that way. Whereas, maybe a parent's comfortable coaching their kid's basketball team, even if they've never really played because they've watched enough. It's maybe a little bit more intimidating for a parent to sign up to coach their kid's robotics team. And so one of the things that we need to do is just lower the barrier to entry to make it comfortable and easy to onboard as a robotics coach or mentor. And in fact, make it so easy that kids can figure out so much of this themselves, that they're very self-guided in what they do.
And as you set up, you have 16 teams, and then you decide to go to Hungary. You leave the teams behind, presumably with some structure. But you kind of got to restart in a new place, right?
Look, that's a part of growing, and actually knowing you've done something successful is when you can be replaced. You've built something lasting when you can step out of it and others can take over and run it. Whether that was the robotics teams at my son's school and seeing that grow and flourish, or in fact, InfoScout, the company I built, of being able to step out, see others step up and take it on and see it flourish. It's actually a great feeling. It's how you know you've done something that's lasting and sustainable. And I think, quite frankly, I hope the same thing happens someday with Revolution Robotics. It's built up to the point where it's growing and thriving, and other people can take it to new heights.
Now, Revolution Robotics specifically, as I was looking through videos and blog posts and tutorials last night, it seems Revolution Robotics is not just a teaching program or curriculum, it's also a new robotics kit that you designed to make things affordable. Is that right? That's
exactly right. I think when I took a step back and said, what is it going to take to really have robotics education and competition thrive? And maybe I could just take a step back further, which is, you mentioned it in the intro to this, which is I'm envisioning a world where anywhere you have organized basketball for kids, you have 5 kids, a coach, electricity, and clean space. If you have those 4 resources, a few kids, a coach, electricity, and clean space, then you should have everything you need resource-wise to offer an organized robotics team for kids. And quite frankly, if you're a school or an after-school organization associated with education, I almost think it should be unconscionable 10 years from now that you could offer basketball to kids at a school and through school, but not offer robotics as a sport or an opportunity to kids. I mean, that's unconscionable. That we would prioritize basketball as a program for these kids, where so few of them are ever going to make a career or living out of it, and yet something that can develop life skills beyond the science and engineering skills. But there's tons of other life skills that I'd love to talk about that come out of doing organized robotics that these kids learn and develop from. I mean, every kid should have that opportunity, and it just really is unconscionable to me that we're not able to offer that to kids today. But that's part of what I'm setting out to solve with Revolution Robotics. Is we have to make it cheaper. We have to make it no more expensive to offer robotics as a program, after school program, than basketball. We have to make it no more complex to offer it as an after school program than basketball. That's really what we're after. And so part of solving that is building our own kit, to answer your question directly, which is the existing kits out there today just don't solve this question of cost and complexity. And to bring the cost and complexity down, we built our own kit. We designed our own kit from scratch. And, some of it's really simple. Like, let's move all the sizes of the pieces to be in standard centimeter increments, because it makes all the mathematics and all the physics of mechanics quite simple and easy to perform and do. For motors and motor controllers and drivers and everything, let's use open source technologies like I2C and others to just make it so that anything can plug and play in. Instead of creating custom cables and ports, let's use standard network cables, T1 cables as our ports. For our microcomputer, let's use a Raspberry Pi. It's open source. Like, let's leverage technologies that already exist, that play nicely together, are much cheaper because they're produced in mass, they're not proprietary, and let's put all these things together and get them working in a way where you get just a really beautiful, simple, extensible system that actually can be produced at a much lower cost than anything out there today.
Now, when I think of the kit, should I think of something a bit like a Lego kit, where there's a manual that tells me what I can do? Or
I think the easiest parallel for anyone to wrap their head around is something like Lego Mindstorms or EV3, if they're familiar with it, right? You buy this kit, you've got a brain, you've got some motors, you've got some other sensors like an ultrasonic distance sensor or a touch button sensor. And you've got structural parts that snap together. Ours people compare to Lego a lot. Ours just happen to be a little bit bigger and allow for larger structures to be built and held together when a robot is doing mechanical type movements and actions. But it's very similar in that regard. And if you get the kit, you're given some guided instructions to build your first robot and code and configure your first robot, so you can remote control it, or you can set it in autonomous mode and program it to do what you want. Very much like Lego in that regard. I think just maybe a little bit simpler and easy to get started, believe it or not, which is kind of hard to believe when you think about easier or simpler than Lego. But actually, that's a lot of the feedback we get, is the onboarding for the robotics, at least, is just a little bit simpler and more straightforward for people.
Now, you've talked about schools, and I want to get back to that. But if some kids or parents maybe thinking ahead to the holiday season, right, want to get a kit, can you individually get a kit, or does it need to go through a school program?
No, absolutely. So on revolutionrobotics.org, we've got a little web shop, and people can go there and order a kit for their kids. Actually, we've sold quite a few that way. And in fact, randomly this last weekend, I met somebody who told me, "Oh yeah, we bought a kit for our 13-year-old, and his younger sibling wanted one, and now they're each building their own robots, and sometimes they're building robots that do challenges against each other, and so it's just become a thing in their family."
That's awesome. Now, what's the ballpark price if somebody wants to get going on this?
Yeah, so the price of the kits is $249 US, includes shipping, and in Europe it's 249 euro.
Nice. Now, when you set out to do this, it seems like you had multiple motivations, right? You were thinking about, okay, this robotics team was so much fun for the kids in Los Altos schools. At the same time, it ties into career. You learn engineering skills, you learn team skills, and so forth. Did you ever also take a step back and think, is robotics naturally the right thing, or could there be yet something else than robotics that's just as natural?
It's a great question. I had to take a step back. Fundamentally, I love the idea of STEM or STEAM, if you call it, including the arts, as a way to really engage kids in a creative form of learning and applying science, technology, engineering, mathematics. And so, look, I'm a fan of a ton of different approaches. I've seen some amazing ones over the last few years as I've been researching this space that I'm a huge fan and supporter of. Robotics is not the only way. Is it the best way? Well, what I can say about robotics is that, one, I've seen firsthand what it can do for kids in terms of really bringing that inspirational joy of learning and applying, the maths and sciences, plus a whole number of other life skills in the process. And two, what you can do with it, both in terms of creating real world challenges and competitions. I think it's hard to replicate and do via other modes of engagement for STEM learning. And so I guess that's what really appeals to me about focusing on the question of robotics and using it as a tool to bring this kind of inspirational joy of learning and pursuing degrees and careers in STEM.
Now, you've alluded a few times to the fact that the kids also learn other skills beyond the science part of robotics. Can you say a bit more about that?
Yeah, thanks for bringing that up. It's actually my favorite part about all of this is what I saw happen with the kids on these robotics teams is, yes, they have to learn how to do some coding. Yes, they have to learn some of the mechanics and physics in order to complete some of the challenges. But what happens in the process is the kids have to communicate ideas that are in their head, a vision that they have. They have to be able to articulate it in a way that their teammates can understand and interpret. And in the process of that, their teammates are going to give feedback. And so if you've got an idea and you're passionate about it, you're trying to articulate it and the other kids aren't understanding, right? We as adults have challenges in terms of getting ideas out of our head and then hearing feedback and taking it in a way that's constructive. And by the way, giving feedback in a way that's constructive. And so the amount of that happens in the course of doing this is incredible. You have to agree on the goal. What are the goals you're trying to solve for, right? We deal with that in business settings every day, any kind of work setting, not just business setting. Planning, like, okay, if this is our goal, what are the steps we have to do to get there? Dividing work among the team members. Okay, I'm going to work on this, you work on this, and then how does that work to come back together and interface to actually make the whole system work? That's not just a robotics question or problem. That's any kind of thought-based work that takes place has these kinds of problems and challenges. And the way that those skills develop through organized robotics is something that I haven't seen happen in the classroom, and I rarely see happen in any kind of other organized after-school program or activity. And these are the kind of life skills that I think we really need to be focused on with our kids to help them succeed in the 21st century.
I couldn't agree more. I think specifically the ability to give constructive feedback is really, really difficult to get that right. Now, the kits are available online, and also some kids have access to the robot kits through schools and so forth. Now, when you have such a, let's say, roughly $250 kit, what are some examples of the types of robots that you can build with it?
Sure. An example would be a robot that can play Jenga. So imagine that, you could have two robots competing against each other playing Jenga. And those could be in autonomous mode or in remote control mode, but you've got to design something that grabs blocks and pulls them out. You've got to grab something that locks blocks. You've got to build some kind of elevator or scissor lift system that lifts blocks up and places them back on top. We've got a Robo Jam coming up here in Budapest, which is a same-day challenger competition where the kids show up in the morning with a kit, and they're given a challenge, and then that very same day, they go through the process of constructing and coding a robot to compete in the challenge that afternoon. And then through each round of competition, they can continue to work on and improve the robot to perform even better round by round as they go through the competition. And the one we'll do this coming weekend is like Hungry Hungry Hippo, if you know the old board game where you have these hippos reaching out for the balls in the center of the field. Well, what we've got is like a little soccer field, and the robots they build will have to drive through their own goal, which kind of creates a size constraint immediately. They'll have to drive in at the start of the buzzer, and they'll have to go out onto the field and they'll have to go grab ping pong balls, which have been dumped out in the field. So they're kind of randomly scattered over the field, and they've got to bring them back through their own goal and collect as many as they can within 60 seconds, while another robot is coming from the other side trying to do the exact same thing. And they get paired up with different robots each round. And so that's an example of the types of challenges. There's so many different things that you can set as challenges. And in fact, our app that we provide for free with the kit is filled with challenges for kids to basically learn and apply new skills while doing something real with the robot.
That's so interesting. A couple of things you mentioned there. One thing is, I mean, when I had Legos as a kid, they came with a paper manual. Right. But what you're saying here, there's an app. You get the app, and effectively, you can get a new manual every day if there's one available, and you can build new things or get new challenges, even if it's not a manual, but more like a goal, a challenge. And I say a bit more about that. What's in the app?
So look, the app has multiple parts to it. The most basics are build instructions for some initial robots, just so they get a sense for constructing how things fit together, how different parts can be used together. There's nothing better than actually doing as a way to learn in some of these cases versus just talking about it. And so we give that opportunity. And then there's an ability to obviously create and configure their own robot. So, I've got motors on the drivetrain like this. I've got motors being used as an arm or a claw. And basically so that they can configure a robot of their own creation, and then they can write code. We use Blockly at this point for kind of drag and drop blocks of code that turn into Python, and what we're using that as an on-ramp for kids to go from block-based coding like Scratch. Blockly is almost identical. As a transition point for them to begin to learn Python, so they can see the Python generated by their blocks, and as they modify their block, they can see the changes. Is what we're working on to offer, so they can write little programs, and then they can assign those programs to buttons on the remote control that you alluded to earlier, and all that's in the app. It's not something separate. It's all in the app. So once they build and control their own robots, then they can start taking on different challenges. We offer kind of weekly challenges in the app, or we've uploaded new challenges every week. And so, a challenge might be as basic as build a robot that can race as fast as possible around the challenge field that we offer with the app. Another one could be one that's going and picking up things and putting them into baskets or little cups of different heights. And so, each one of these challenges is kind of a fun way to put the skills to the test. And I think that fundamentally at the end of the day, what we're after is the kids are learning skills that they then creatively apply to solve problems. And there's a learning taxonomy called Bloom's taxonomy that says the highest form of learning or understanding is when you can creatively apply the knowledge that you've learned. And I think that's another amazing thing that robotics offers that's hard to deliver through other kinds of educational vehicles. Now,
Jared, I can tell your passion is, if anything, primarily around the kids' experience and the kids learning
Absolutely.
And building teamwork skills and so forth. But I'm still curious, is there any favorite robot that one of the kids or one of the teams built that you can highlight?
There's one I've seen that the kids took our motors and they did all kinds of compound gears, where basically, you basically use it to help, something spin faster and faster than the motor actually spins at the end of the day. And they attached 2 tires to it, and they used it as like a shooter in the way that maybe you've seen in baseball, a pitching machine, or in tennis, like, shoot tennis balls. And so they built one of these, and they popped ping pong balls through it, and the velocity and at which these ping pong balls came shooting out. I mean, you'd literally want to duck because they might give you a welt if you got hit by them. So they had a lot of fun building this kind of like almost like a tank shooter that's just darting ping pong balls at any target they set.
Yeah, that's very creative. And maybe one of them wanted to play more ping pong and didn't have a partner.
Maybe that's it. They needed a partner for ping pong, so they built that.
Now, when people think robots, the first thing people tend to think is the physical, of course, because it makes them tangible. You can touch them, play with them. Mm-hmm. But as you already alluded to a little bit, a big part is the software, right? And And in some sense, if we think about jobs, there will be many jobs related to robots in the future, but even more so, most likely, related to software than robots. And so I'm curious about your thinking on that, and how big a component is software in everything that the kids are doing.
Yeah, it's a huge component. In fact, I love what you mentioned there about jobs. I mean, so many jobs are being automated, and mostly by software. I mean, there's the famous saying of software is eating the world, and it's clearly just taking over more and more jobs. In fact, I was flying this last weekend, and it was just amazing to me as I experienced the whole check-in process for thousands of people at the airline. And there were only 3 people at the check-in counter because they'd automated it all through the kiosks. And, you're checking in yourself, you're providing your ID and confirmation, and you print out the bag tags and you put them on yourself. And, it's basically just automated the role of the check-in counters. And we see that in so many areas. And one of the things that I've thought about is this is going to continue to happen, the levels of automation. And we probably want our kids to be in a position where they understand what's and envision what's possible with robotics and automation, and don't put themselves in a situation where they're fearful of what robots can do or will do in terms of automation, but they feel empowered and that they know how to make a robot do what they want towards automation, right? And so put the kids in the driver's seat where they understand more what's possible and where this could go, and they can envision it, but also that they can see their role in it, which is almost defining what the robots of the future will do. And I think that's really empowering for our kids in a time what's quite frankly uncertain for where jobs are headed in the future here. And as for the software component, I think you're right, which is more and more automation is really through the software side as opposed to the hardware side of things. I think there's a big role for the integration of the two. How software works with hardware and the interface and the leverage between the two is often where the magic happens. But there are more and more opportunities on the software side. And having built a couple of software companies, I guess I'm particularly partial to that side. And so what I view in this is robotics is an amazing way to teach kids how to code and what code can be used for. I think the online programs like Scratch and what Khan Academy has done, those are excellent. They're excellent teaching programs. I also think there's no substitute for actually controlling something physical in your presence, mechanical, with code that you've created. It's different than when you're controlling a character on a screen. There's a ton of value that comes from that. There's also some unique value that comes from building something yourself, your own creation, configuring it, and then coding it so that it becomes smart and intelligent and aware of the environment around it and capable of interacting and responding with the everyday world that you also occupy and interact with, whether it's, opening your door to your room, picking up the socks, throwing them in the laundry hamper. There's a mechanical component, but getting that to work requires a fair amount of coding, and we're trying to provide that onboarding path to kids to start learn to code, but have a reason to code as well. Right now, they have this thing that they built and they want it to work. Now they have a reason to code, and if you give the kids a reason to do something and an objective and a challenge, they'll figure it out and they'll be more passionate about it, doing it than if it's just some kind of random thought experiment.
Fully agreed. Now, when I was going through the blog, one of the things I saw is that there was a whole section in the blog on actually convolutional neural networks and computer vision. And I was like, wow, that's pretty advanced for kids to get started on robotics, to dive into all of that. How do you see the kids ramp up to that? That's kind of like the state of the art in artificial intelligence today. Was like,
yeah. Well, look, sometimes you have to throw some big audacious vision out there to give people a sense of what's possible. And I think hats off to my head of engineering. I got to give him a shout out, David Dudash, who's led the design of this and who wrote that blog post. He actually took our kit and added, a camera system. He's also added LiDAR to it before, by the way, to make a self-driving vehicle to our kit, which is really incredible. But one of the things we did is with the Raspberry Pi, we left the ports open so you can plug in a camera, and you can do things like create your own line following code using convolutional neural networks, where it's actually interpreting what it's seeing through the camera and guiding the robot to respond in something like a line following scenario. And so one of our ideas was, we have all these ports and capabilities with the Raspberry Pi. We could close them in because we don't actually build the parts to support them, or we could leave it open and say, look, the sky's the limit. If a kid graduates beyond what they can do with our kit, wouldn't it be nice if they could attach their own motors, if they could attach cameras, if they could attach something else and just continue to develop their own skills and interests well beyond what we're able to provide ourselves. And that's really, in line with our vision for where this goes. We want this to be an onboarding, not an end goal. This is a start towards a career, an interest in STEM, not an end destination.
Now, I'm curious if somebody buys the kit and they're just alone, let's say maybe their school doesn't have a team yet, can they still be part of a community? Is there any way to help them get a team started at their school? What do you offer in terms of community building?
Yeah, so this is really the next phase of what we're working on right now. It's a great question. I wish we were further along. Quite frankly, COVID probably set us back a year and a half from where we would have liked to be in terms of building out programs in local communities and supporting the onboarding and ramping. We're actually building up some programs now, like in Queens, New York. There'll be an after-school program at all of the middle schools. We're working with Stockton, California, and other locations to build this up. If individuals want to do this today, they can certainly ping us through our website, and we'll provide them with some support. We have program managers in the U.S. who work with interested parents in particular, or teachers, to help them get started at their local school or Boys and Girls Club or other organization to set them up to be successful and get a program going.
What's the age range for kids to engage in this?
So the primary age range that we're supporting is ages 8 to 13. So this is basically your fourth graders through your eighth graders is really the sweet spot with the kit that we've created. We think much younger than that, there's some things we'd want to do to further simplify the design of the brain and the interactions. Certainly with parents, we see kids ages 5 and 6 having a great time with the kit.
Parents.
And the parents. Well, that's actually it. Quite often, if they're enthusiast parents who want to get their kids started and they're ready to be hands-on with their kid, they have a great time at ages 5, 6, 7. But for a kid to be able to work on this mostly independently, you're looking at around age 8, and then they can keep going up to about 13. By the time they're ready for high school, what we found is typically they're ready for almost direct Python programming, like line by line, which we're still working on. And then parts-wise, they're usually ready to graduate from injection-molded plastic parts all the way up to metal type parts and much stronger motors and other mechanics.
Now, do you have any favorite stories from teams or kids and parents working with a kid?
Well, I can just think of one recent one that just came up, which is I was at a wedding over the weekend, and I met a parent who'd bought some of the kits, and their kids have been using them. And the kid, pretty advanced 13-year-old, is building his own 3D printed model car, and he was trying to understand how differential gears worked and operated, and to get a sense of how it worked and came together, and how we might be able to do it in this model car that he's building. He actually used our kit to actually figure out how to construct a differential gear and understand the mechanics of it, and to be able to even conceptualize how it was all going to come together, so that then he could try and 3D print it for his model car. And I went, 13 years old doing this. It's incredible. But also how awesome to know that hey, there's Lego, there's other tools out there, there's YouTube, there's other ways he could have learned and tried to understand this. He chose our kit as the means by which he could construct and understand how this works together and how the mechanics actually work.
No, that's an amazing story. I got to imagine the best feelings for you must be situations where people you didn't know got a kid and don't even know that you're part of the team tell you about this kid.
It's an amazing feeling. It's when you know you're starting to have some semblance of an impact towards what you set out to do. And certainly we have a long ways to go. We're just getting started. We're only scratching the surface, but it's nice to see just these early bits of feedback of the impact we're starting to have on kids.
Now, talk about just getting started, early days and so forth. It's my understanding you ran a Kickstarter to get this going.
Right.
Can you say a bit more about that process?
So look, Kickstarter's fantastic, and Indiegogo and all of these platforms is a way to say, I've got an idea for something. I think the world needs this or wants this. And if I can get enough people who share that passion or interest who are willing to contribute here, then I'll have both the confidence and maybe the financial capital required to get this going and kicked off the ground. And in our case, you could imagine we've got hundreds of parts in this kit. This is a pretty significant kit, and so the tooling cost was immense in terms of creating all the injection molds for these parts. And so you really want to know that there's some interest and demand out there before you go spend the money to do all that. And the upfront manufacturing cost is significant. I mean, these kits are hundreds of dollars, and you're going to produce thousands in production run. That takes some capital, and so that's an advantage of something like Kickstarter or Indiegogo to get a concept off the ground. And fortunately, actually, there's a lot of great robotics and STEM educational type initiatives out there. So it's not a foreign concept to do that on Kickstarter, Indiegogo, and so we did that, and we did this opportunity to basically find people who are willing to take a chance on an unproven idea or kit and allow us to bring it to market on a timeline that we set out to deliver by Christmas, which was only 6-7 months away, which was potentially too aggressive, but my amazing team actually pulled it off, and we delivered our kits just in time for Christmas gifts for kids out there. So that was outstanding that we could make and meet that commitment. But the other thing is it set the right expectation with everybody of, look, this is a minimum viable product. This is our first draft. We've put a lot of thought and energy into it, but there might be some bugs or other things, and that's part of what you're buying by being a Kickstarter backer. And I just think that's amazing as a way to launch a new product in a way that just didn't exist before, where you almost had to get it right the first time because there wasn't going to be a second chance. Or Kickstarter allows that opportunity to get a minimum viable product out in the market to begin with from early adopters, and then use that feedback to refine and build maybe a future version of the product, which is exactly what we're doing.
Yeah, and just to be clear, you said the Kickstarter version might have some bugs, but that is a past generation. Today's kits are much refined beyond that. Sure,
absolutely, and we've just learned a ton through the experience. We kept iterating as the first users would get on board, and they'd experience something, and we'd go through cycles and cycles of engineering to just improve the experience. And so now we're 2 years into that, and in fact working on what we call version 2 of the product coming up here next summer that we think is going to just be an amazing product that we have full confidence in really going global with.
Now, I think anybody considering Kickstarter, one part of the process is the vision. Right, you need to have a vision that's compelling, but another part, right, you somehow need to get people's attention. Right, yes. There's a marketing aspect to it, I gotta imagine. And I'm curious, what did you do to make sure that people saw it and came to listen to your story?
I'll be frank. I think we could have done more and better around that. One of the things that we tried to look at was segment the market in terms of who are the types of people who are going to express an interest in this kind of product at the early stage. And one of them is really Raspberry Pi type enthusiasts, people trying to maximize what they can do out of Raspberry Pis. And so we could find these audiences online in all kinds of different forums. And, we could provide little links or mention to our Kickstarter campaign. We could provide feedback on their posts of what they had done and say, oh, that's awesome. Check out what we're doing over here and include a link. And so not only would that enthusiast who had posted something see that, but potentially other people who are viewing their content of what they had done with their Raspberry Pi would see ours as well and click on the link back to the campaign. So, whether you call that grassroots or guerrilla marketing, we were doing everything we could on a budget, considering we're a nonprofit organization, to keep the cost down and just be really effective with our outreach. And so STEM educators for others, existing robotics program coordinators or teachers of robotics, we were finding where are these people online, where are they interacting with others who share their passion and interest, and how do we get ourselves inserted into that conversation with a link back to the Kickstarter campaign.
And did you have any kind of early demos that were part of the campaign video?
Well, we did. What's funny is We hadn't done the injection molding yet. So the only thing we had was 3D printed parts. And I don't know if you've worked with 3D printers, but there's a huge range of a spectrum and capability. And the ones that only cost a couple $1,000s, if you're talking about printing Lego Technique quality parts or more, which I'd like to describe our parts as, well, you're just not going to get the pins to fit very well into the holes with 3D printing. It's just not going to work that way, and maybe the colors aren't going to be as vibrant of the 3D printed parts. So literally, we printed parts that we found ways to force together to act like they were snapping together nicely, and my daughter helped me paint them the different colors so they look like the real parts and other things. And we built robots that worked, but maybe didn't look fantastic. And if you see our video today, that's exactly what you'll see on the site is from that Kickstarter video, as opposed to the actual final produced kit, which is a much higher quality product.
That's a great experience too, though. I mean, it's a lot more expensive to 3D print per part once you're at scale than injection mold, but it's also fun, right? To see it just materialize in front of you.
So much fun. And the ability to iterate, take some, that's not going to work for this reason. Sometimes you don't realize that till you have the physical parts and you put them together and you start using them for how they're intended. Or maybe in the process, you realize, there's other ways to use this. And if we modify X or Y, it'll work for both use cases. That you just can't think through otherwise. Sometimes it just takes having the parts and using them, putting them together to realize things that maybe you hadn't taken into account. So 3D printing for us was an invaluable part of the prototyping process.
Now, Jared, the journey you're on is absolutely amazing and really still in the early stages. Clearly, you see this as something that could be in every school, right? Many robotics teams and so forth. Every household, every kid could be playing with robots and learning along the way. Now, if any of our listeners wanted to help support Revolution Robotics get there faster, in a more comprehensive way, how can they help?
Well, first and foremost, we'd love to have parents, teachers, mentors who would love to lead a group of kids through the experience of learning all of these skills related to robotics and, of course, all the life skills that come along with it. So they can contact us through our website. Beyond that, a number of individuals and companies have sponsored programs at their local community center, at their local school, at their local Boys and Girls Club. We're always looking forward to working with more people to get programs in place at schools and organizations. And so that can be done through our donate page, or if there are any questions, just reach out to us on our website. But we've got some great partners out there. DuPont, I'd love to name, is a recent one that's really done some great work with us, reaching kids who otherwise wouldn't have these kinds of opportunities to make sure that they get exposed to what can be the inspirational joy of organized robotics.
So many ways to help make this dream happen. Well, Jared, thanks for sharing and thanks for being on. This has been an absolutely wonderful conversation, and I really hope it inspires and gives opportunities by learning about this to many kids out there to get involved in robotics and all the skills they'll learn along with it.
Thanks so much. Really appreciate being on your show, Peter. Thanks.